All right, angle R, 120, 124 degrees. The AF and DF are congruent. Somebody help me get to angle AFD, that's top angle. All right, it's a parallelogram. All the properties exist. Can anybody put another angle measure somewhere on my diagram? What's another angle you're confident in? Boom, boom. 20, another angle you're confident in. Parallelogram, start using some properties here, Jonathan. Yep, great. 124 right here, opposite angles congruent. It's a parallelogram property. Get me more, feed me, come on. What else you got? 22, something else we know. The 124 and FAD are supplementary. Good, so this will be 56. What type of triangle is FAD? 10, what type of triangle? What's across from the congruent sides? There we go. Angle A is 56. I think we can find AFD now. Angle AFD. 13. 68. Good work. Now, did you have to go just like we did to get there? No, you did not. No, you did not. You could have said consecutive angles are supplementary. Alternate interior angles are congruent. A lot of different ways we could have got there. Any questions on that one? All right, let's get into what we're really talking about today. That finishes up yesterday. Similar triangles, everybody. Similar triangles today. Whew. All right, let's do this. I started off with a tough one right away. Angle H, everyone mark it with the arc mark, congruent to angle RDO. Let's label our sides now. RD is 4, RO 6, OH 4, and hey, how about the length of CD now? All right, first thing. I know it's a similar triangle. I've done this problem 6 times. All right, I know it is. But on the test, how are you going to know those triangles are similar? What's the main method we have to proving triangles similar? What do you got for me? Angle, right? Well, I already gave you one A. Where's the other A? Where's the other A? Mahmoud, let's roll. Everyone, angle R is congruent to itself in both triangles. Great job. So do you see why the triangles are similar? Okay, we got the triangles are similar, so now I know the sides are in proportion. And this is a bear of a problem to try to match up the sides, to try to turn the angles so they match up. So here is a strong piece of advice I would take. How do I match up the sides? Figure out, write down what the congruent angles are. So we already know from the givens, angle H is congruent to angle RDO. So that means the sides across from them correspond to each other. Ready? What is angle H across from in the big triangle? Name the side. CR. So that means CR matches up with, name the side across from RDO in the small triangle. Those are the two that match up. They're across from the congruent angles. Let's keep going. Angle R congruent to angle R. In the big triangle, name the side across from angle R. What is it? C. So CH corresponds with, name the side across from angle R in the small triangle. O. D. Everyone with me here? How I'm finding out they got to be the sides across. So that means the last pair of sides, which, let's see, what pair am I missing now? From the big triangle. I'm missing HR. HR would have to correspond with, what's the third side we don't have written down in the little one? I have OD, I have OR, I have DR. So those sides match up. All right, you ready to write your proportion? 20. Give me a side in the small triangle we know.
Side DR is 4. And,
Oh, ready? Yep. DR corresponds with what?
HR.
Which is?
10.
10. I don't know how many of us are going to figure that out trying to visually turn it or maybe draw it out. But now I know they're across from the congruent angle, so they have to match up. Name another side in the small triangle. Jonathan took the 4 away from you. 6. 6. What other side do we know? 6.
No. 6.
6. Yeah, there we go. See, you got that, Lauren? Good. That's why I kept repeating it. What's the 6 correspond with in the big triangle? 9. What does OR correspond with in the big one? Which, how do you write that? Here we go. Cross them up. The corresponding sides will always be across from the congruent angles in similar triangles. Always. Don't make it difficult on you. $11. We could cross multiply there. 11. All good. All right, keep grinding. Anybody, ask away here. This is your time here. AC, perpendicular to DE. Again, I know they're similar because I've done this quite a bit. How are you guys going to know they're similar? Where's the angle here? Where's the angle here? Mahmood, give me a pair that you know are congruent. Angle A and angle EDB. It's been a while, but you want to tell me what type of angles those are? Oh, corresponding. There's one A. What about another A? Where's the other A up here? 2 places. You should go with Caitlin. B is reflexive, or you could have gave me the other pair of corresponding angles. So that's why those triangles are similar, AA. All right, let's match up the sides now. This one's a little bit easier to match them up than the last one. I don't need to, say what's across from the congruent angles, I don't think, but 12 DE is 4. What's AC? I think these are a little bit better. Here's the problem I don't want you to come into. Full sides only. Full sides only. 24 should not be in your proportion. Full sides only. Go ahead, set it up. I'll ask somebody for their proportion. Give me your proportion that you set up for me. Give me it. 12?
12 over 36.
Nice.
4 over X.
If it didn't match yours, don't erase it. Don't erase it. Are you at least cross multiplying 36 and 4 and 12 and X? If you are, you got a great proportion. All right? You got a great proportion if you're doing the same cross multiplying we are. And what the heck what did this come out to be? 12? So sometimes it's easy to match up the sides, sometimes it's not. But you got to weigh now. You got to weigh. Anything here? We're going to keep going with the similar stuff. Oh, that's on day 2. Yeah, here we go. That's all I talked about today. Angle. Woo-hoo! Ho-ho! We got 2 other methods, though, we could use. Angle. I know it's up there already, too, but go ahead. Anybody? Angle. What are the other 2 methods of proving triangles similar? Serena?
Side angle, side.
Similarity. The sides have to be in proportion. The angles in between congruent. And then there was a third one. What?
Side.
All 3 sides are in the same ratio. Yes, all 3 sides are in the same ratio. Now I know I put the answers here already. Now number one they are similar because of side angle. Here's why. Take a look. I wrote side angle side because 12 over 4 is in the same ratio as 9 over 3. Agreed? So that's why it's side angle side. Angle. I think number 2 is obvious. 3 is a hot mess, right? I don't think that's probably going to be our answer because is the angle in between. And they're not even in the right ratio anyway. So yes, 3 is going to be our answer. Those are the ones that are not similar, but I'm still interested in hearing what you have for number 4. Why are those 2 triangles similar? What's up, Maddie?
These are isosceles triangles.
Well, watch your mouth. They're not isosceles.
Oh wait, they're not.
They're not is. Why can I say those are similar? What do you got on your mind? You could say side angle side, and not only are they similar, what are they? They're congruent by side angle side. So you could say congruent triangles are similar. Can't go do the other way though. Only congruent triangles are similar. But again, you could do side angle side similarity. They're in a ratio of 1 to 1. All good. Having a good time so far. Yes, we are. I'm telling you these 2 triangles are similar, ADE and ABC. Okay, if they are, which one of these 4 measurements would show they're similar? Okay, so which one of these 4 would be a correct ratio if I set them up? Go ahead. I'll let you test out each one. You know they're similar, so their sides have to be in proportion. All right? Which 4 measurements put their sides in the same ratio? Which 4 measurements say they're similar or show they're similar? 5? Number 4. Hey. 2 to 6 is the same ratio as 5 to 15. 1 over 3, 1 over 3. Any questions? We're doing all right? All right. Which one's going to show by side angle side that they're similar? Which measurements and angles? Remember, side angle side, the angle has to be in between, and the sides need to be in the same ratio. Where's my copy? What sides did you find in the same ratio and the angle in between was congruent? 6 when you're ready. 4. You got DE 15, DF 20. Okay, right now though.
I had 1. That's the actual answer.
Where did 4 come from?
Avery. I did not tell you that. You're normally right.
Well, first of all, why is 4? I'm not even going to test the sides. Why am I not even going to test the sides? C and F, are they in between? No. So even if the sides are right, doesn't matter. C and F aren't in between. I at least got to pick something with A congruent to D, right? And that would be choice 1. All good? Is Avery taking the test for you in 4 weeks? Okay. Be yourself. All right. Prediction?
Solid 90.
It's right on 90.
I'll go for 100 though.
Okay.
If I already know if I get 100 what you're doing. You're getting me.
Good. I'd love to hear what your 100 challenge is for me. If Lauren gets 100, go ahead.
A Dunkin' iced coffee every Friday.
Maybe for a quarter. I'm not doing this every Friday. We can negotiate. Maybe for a quarter we'll do it.
Okay. Or maybe like once a month, maybe.
Okay. 10 weeks, 10 months.
Every other week.
Okay, we're good. We're good. You get that 100 first, all right, and we'll talk.
Okay.
All right, you get that 100 first. And I'll assume you won't be coming up and getting it.
I will.
Oh, really?
I'll come and get it. If you're
Actually, you know
buying
what? If you get the 100, I'll throw in. I'll deliver it to whatever class.
Really?
Yeah. I'll deliver it. Yep.
I'm gonna be
Hand
sending
delivery.
it tomorrow.
Yep.
That'll be great.
All right, you got it.
Will that mean does that mean you have to say hi to me in the hallway too? Cause
Absolutely not. No.
So you're just gonna walk in and
I'll just walk in and be like, Lauren? And then if you really want it, you'll raise your hand and I'll come and put it on your desk.
Okay.
All right? Because you are correct. I do not know any of you. Once you give me that Regents, June 21st, wherever we are, done. Memory lost. All right, one more similar triangle one here. Are they similar or not? So you got S and Y congruent. And then I give you RS is 6, ST 14, XY 9. You better hold your horses before you say side angle side. The sides have to be in the same ratio. So are you figuring out, is 14 to 21, is that the same ratio as 6/9? Because it's not it's not angle or side. So it's got to be side angle side, but let's make sure the sides are in a ratio. Are they in the same ratio, those sides? 8, are they in the same ratio? They're not? Okay, take your time.
They are.
They are, yep. How do you guys figure out, by the way, if they're in the same ratio? Not a lot of people know that. I know a lot of you probably type it in your calculator, either A, see if the decimals are equal, or B, see if your calculator reduces them to the same thing. You can cross multiply too. Is 6 times 21 the same as 14 times 9? And they're in the same ratio. So I don't know if anybody wants to take that up. I don't know. So yes, they are. And it says justify your answer by side angle side similarity. Good. And then we always have one of these problems seem to come up. How many degrees will it take to carry it onto itself? First of all, I didn't go easy here on you. Decagon. 10 sides. So I need to first figure out if I rotate a decagon from one vertex to a consecutive vertex, how many degrees it is. And the easiest way to do it is go all the way around 360, divide by the number of vertices, 10. So every time you go 36 degrees, you'll get the same decagon back because you're going vertex to vertex. Unfortunately, that's not a choice, right? So does the answer not exist, or did we do something wrong? No. Every time you go 36 degrees. All right, 36 isn't there. Let's go another 36 degrees. 72 would work. I really put it to you on this one, didn't I? Another 36. 108. Another 36. 144. This guy. 180 would work. 216 would work. 252 would work. There we go. We'd get there eventually. Do you want to talk shapes? Octagon? How many? 8. Pentagon? 5. Hexagon has 6 sides. I don't see them going 9 or 11 or 7, but 7. Sept or heptagon. Yep, that's 7 sides. Okay. All right, all good. All right, let's go to dilations now. Dilations. Line L is going to be dilated by 2. What's the new equation? First thing we got to remember, when I dilate a line, what stays the same? Okay, I dilate a line. What do I know about the original and the new line? Always parallel, so Griff will have same slope. Anytime you dilate a line, it remains parallel. The only thing that's going to change is the y-intercept. First thing I want to do, get this bad boy into y equals form, so I know what the slope is and the y-intercept. First move, get in y equals form. 2's 22. Subtract 3x, good call. Negative y equals negative 3x plus 4. That's not good enough because I have negative y, so how do you want me to get rid of the negative y? Or the negative in front of the y? Oh, 13? It's really a negative 1, remember, times y. So it's being multiplied already by negative 1, so to get rid of it, divide both sides by negative 1. 3x minus 4. So we already know the new line is going to have an equation y equals 3x and something else. Because dilated lines remain parallel, so their slopes are equal. Now, how do I find the new y-intercept? Use the scale factor, 2. It's getting twice as far away. Or multiply it by 2. Our new y-intercept is minus 8. Okay. Everyone all right? Next up, what about if I dilate a triangle by 3? Which one up there is a true statement? Can we just get rid of 2 of them right away? Can we get rid of 2 of them right away? Paul? 3 and 4. All right, 3 and 4. Here's why. When you dilate a triangle, the triangles remain similar. And what do you know about angles of similar triangles? They're always what? Congruent. Yeah, so I'm not multiplying the angle measurements by 3. The angles remain congruent. Now you got to look at 1 and 2 and say to yourself, what is actually getting multiplied by 3? The original or the image? So what's getting multiplied, or scale factor of 3? What's getting multiplied by 3? What do we think here? The original gets multiplied. Which one out of your choices 1 and 2 are the original getting multiplied by 3? Choice 2. Anything? All right, let's keep going here because I still got a bunch here to do. I'm going to dilate a triangle by 3 again. Which statement's true? Anybody want to eliminate any that are definitely false? Because this is what I want you guys to do. You may start panicking. You might not know the answer right away, but at least you can start eliminating ones that you know are definitely incorrect. So I just dilated a triangle by 3. Which one? Anybody want to just get rid of 1 or 2 right away? Jonathan?
3 and 4 we can take away.
Good.
The slope would stay the same. It won't become 3 times the amount. And the angles will stay the same. They won't become 3 times the amount.
Perfect. We just talked about these 2 things. When you dilate, angles remain the same because they're similar. When you dilate, the lines remain parallel, so slopes remain the same. So now here comes the question. Is the area increased by 9 times or the perimeter increased by 9 times? I'm going to go back to Unit 11 with you guys. Remember doing S1 over S2? Right? Everyone remember doing that? That's similarity ratio. That's your scale factor. Anybody remember what it's always equal to? What other ratio? Which one was it always equal to? Perimeter or area? Perimeter. So guess what? If the triangle got 3 times bigger, so did the perimeter. What did we do on this one to make them equal? Because that's not true. What did we do on this one to make them equal? We had to square them, right? So if I went 3 times as bigger, if you square 3, the area got, wrong one, 9 times bigger. Perimeter got 3 times bigger because they're always equal. Area, 9 times because I squared. Any questions, comments, concerns? A lot of similarity today, huh? That's the big topic for today. I think we're going to end class on these 2. Still similarity dilations. ABE is the image of ACD. So everyone see, ACD was my original, ABE is my image, my new one. All right, can we stop right here? Am I getting bigger or smaller? Smaller. Can you eliminate 2 choices right off the bat? Just because the triangle got smaller. Which 2 can you eliminate right off the bat? Just saying, oh, the triangle got smaller, so it can't be 22? Bigger than 1, right? Can't be bigger than 1. So it's either going to be 2 over 3 or 3 over 4. What is the ratio of BE to CD? Now, could we bust out our distance formula, find the distance of EB and DC, put them over each other and roll? We could. We could do that. But there's got to be an easier method here than doing that. BE to DC is going to be in the same ratio as what other sides? Give me another pair of sides it's going to be in the same ratio as. BE and DC are in the same exact ratio as what other pair up here? 18?
Like DA and EA.
Okay, so AE over DA. I could have also went AB over AC. And why is that a little bit easier doing than busting out distance formula? You can count how long they are, right? How long is AE? AE is 4. How long is DA? 6. Not a choice, but we can reduce it down to 2/3. All good? Don't get out distance formula if you don't need it. And finally, what's my scale factor here? So let's just make sure we know CD is the image of AB. So AB is the original, CD is the image of what I'm left with. What's the scale factor have to be? Ooh, tough one here. Think of it this way. Think of it this way. What's ED match up with? E to D is in proportion with E to 7. E to D, same ratio as E over B. That's not a choice, though. Son of a gun. It's correct, but it's not a choice. All right. That would be, let's go DC over. What would DC be in the same, all of them? DC and 15? BA, yep. Son of a gun. Not there. So I guess I got to take the third pair, right? What's the third pair? 20. EC over EA. Oh, hold on. Before I circle that, I see EC over EA and I see EA over EC. How do I know which one? You ready, Paul? How do I know which one to pick?
Number 1, because you're getting smaller, not bigger.
The line's getting smaller, isn't it? So I want something less than 1, so I want the smaller one on top of my fraction. Everyone see that? I need a scale factor that's less than 1, and the only time I can do that is if the smaller number's in the numerator. So that's why it's going to be EC versus EA in the numerator, because it's smaller. Good job, Paul. And I think that's a good breaking time right here, because the next one starts some SOHCAHTOA stuff tomorrow. So that's a good breaking point right there. All right, you guys know the problems I'm suggesting. What do I have tonight? 15 through 27? Okay. Try them out. Iced coffee delivered. Okay. That's actually